Next chapter is the periodic table, that is the periodic properties of the elements. Before going to study this periodic table chapter, you should have the complete awareness about the atomic structure in that very particular electronic configuration of the elements. Under what S atomic orbital, P atomic orbital, D atomic orbital and F atomic orbital, how the electrons, the distribution in these atomic orbitals. Yes. Now what do you mean by atomic orbital? Orbit and orbital. Orbital is a three-dimensional space where we can observe the maximum probability of the electrons. There are 5 atomic orbitals: S atomic orbital, P atomic orbital and D atomic orbital and F atomic orbital. These P atomic orbitals are further classified into Px atomic orbital and Py atomic orbital and Pz atomic orbital. And D atomic orbitals are classified into 5. There are 5 subatomic orbitals. There are dxy, dyz, dzx and dx square minus y square and dz square. These are the subatomic orbitals of the D. And yes, it has only one atomic orbital, that is a small letter S itself. Now each atomic orbital has capacity for the accommodation of only 2 electrons. That is why S atomic orbital we can place only 2 electrons. Here in case of the P atomic orbital, we can place, in case of the P atomic orbital, we can place 2 electrons in Px atomic orbital and 2 electrons in Py atomic orbital and 2 electrons in Pz atomic orbital, total 6 numbers of the electrons. Therefore, we can accommodate 6 numbers of the electrons in P atomic orbital. And in case of the D, we can place 2 numbers of the electrons in dxy atomic orbitals and dyz we can place 2 electrons and dzx we can place 2 electrons and dx square minus y square we can place 2 electrons and in dz square we can place 2 electrons. Therefore total we have 10 numbers of the electrons. Therefore 10 electrons can accommodate in D atomic orbitals. And F atomic orbital, similarly it is a complicated atomic orbital. 7 subatomic orbitals will be there. Therefore we can accommodate 40 numbers of the electrons. Please remember how many electrons we can accommodate. You have to write one add number series, that is 1, 3 and 5 and number 7. Then multiply by means of the simple even number, that is 1 into 2, 2 and 3 into 2, that is equal to 6 and 5 into 2, that is equal to 10 and 7 into 2, that is equal to 14. In future we have G atomic orbitals also there, that is a future form of the modern periodic table, or G atomic orbital. Whereas G atomic orbitals we can place 80 numbers of the electrons. This is the number of electrons we can accommodate in S atomic orbital and number of electrons in P atomic orbital and number of electrons in D atomic orbital, number of electrons in F atomic orbital. In future we have G atomic orbital. Therefore G atomic orbital has capacity for the accommodation of 18 number of the electrons. This is the brief history of the total number of the electrons that we can accommodate in each atomic orbitals and subatomic orbitals. Okay. Now you should have the awareness about the distribution of the electrons, that is 1s, 2s, 2p, 3s and 4s and 5s and 6s and 7s and 2p, 3p 4p, 5p, and 6p, and 7p. Here we have 3d, 4d, 5d, and 6d. There is a 4f and 5f. See how the electrons that enters in each atomic orbital. Here, electrons that first enters in 1s atomic orbital, followed by means of the 2s atomic orbital, followed by means of 2p atomic orbital, and followed by means of 3p and 4s atomic orbitals, and 3d followed by means of 4p, followed by means of 5s, 4d and 5p, 6s and 4f, 5d, 6p, 7s, 5f, 6d, 7p. Remember this diagram. Here the first one is 1s atomic orbital. First one is 1s atomic orbital. Followed by means of 1s atomic orbital we have 2s atomic orbital. Next 2s atomic orbital next, followed by means of 2p atomic orbital. Then 2p followed by means of 3s atomic orbital. Now next to 3s we have 3p atomic orbital and 4s atomic orbital and 3d atomic orbital, 4p and 5s atomic orbital and 4d atomic orbital and 5p atomic orbital and 6s atomic orbital, followed by means of 4f atomic orbital, 5d atomic orbital and 6p atomic orbital and 7s atomic orbital, followed by means of 5f atomic orbital and 6d atomic orbital and 7p atomic orbital. See, the energy level are in increasing order. Energy level of this 1s smaller than 2s. Energy level of 2s is smaller than 2p. Energy level of 2p is smaller than 3s. Energy level of 3s is smaller than 3p. Energy level of 3p is smaller than 4s. Energy level of 4s is smaller than 3d. Energy level of 3d is smaller than 4p. Energy level of 4p is smaller than 5s. Energy level of 5s is smaller than 4d, and so on. Sir, how can I check the energy level of an electron? That you already studied by using one law, that is a principle, that is the n plus L rule. N corresponds to the principal quantum number and L corresponds to the azimuthal quantum number or subsidiary quantum number. According to n plus L rule, n is equal to, for example, for 1s atomic orbital, 1 is n value is equal to 1 and L value for s is equal to 0. L value for s is equal to 0. Therefore, 1 plus 0 is equal to 1. Similarly, for 2s atomic orbital, for n value and L value and n plus L value, you can record, assume L value is equal to 0 for s atomic orbital, 1 for p atomic orbital, 2 for d atomic orbital, and 3 for f atomic orbital. Now, for example, 2s atomic orbital, n value is equal to 2, yes, L value is equal to 0, n plus L value is equal to 2. For example, 2p atomic orbital, Example, n value is equal to 2, P for L is equal to 1, now this is 3. Check it for 3D atomic orbital. N value is equal to 3, L value for D is equal to 2, and total value is equal to 5. And for a 4f atomic orbital, then n value is equal to 4. What about the coefficient value? L value for f atomic orbital is 3. Now this is equal to 7. Now check any one of the atomic orbital, then identify the n plus L value, that is found to be 1, here found to be 2, L2p atomic orbital, that is equal to 3. Now 3s atomic orbital, that is equal to 3, and for 3p atomic orbital, that is equal to 4, and so on. You have to determine the n plus L value. They are gradually in the decreasing order, increasing order. But if for the two of the atomic orbital, now this is 2 plus 1, this is 3 plus 0. Now according to n plus L value, if the n plus L value of the both atomic orbitals are same, then electron will enter into the one of the atomic orbital whose n value is minimum. Therefore 2p and 3s atomic orbitals, they possess the same value for the n plus L value. Therefore the electron will enter in 2p atomic orbital first, followed by 3s atomic orbital. Is it clear? This is about the brief history for the electronic configuration. Now this is very important. This diagram is called energy level diagram, or you can give an example for Aufbau principle. Electrons will enter in lower energy level first, followed by of the higher energy level. Now see, now we have so many elements in the modern period table. Every day we are discovering, suppose the new element, then we are not yet nomenclated the new element, because we are not yet studied the properties of these elements, that is periodic properties of these elements. In 18th century, we have only 30 different elements were there. In 18th century, we have 30 different elements were there. But in 1865, we have around 61 elements will be there. 61 different elements will be there. Now at that time, whenever the 63 elements. Now we have more than 116 elements. 116 elements. Now in 2020, we have more than 60 elements. Now in the 18th century, where only they discovered 30 different elements. Now in 1865, the number of elements exist were found to be 63, and now we have more than 116 elements. Now whenever the number of elements were 30, now why the classification of the elements that requires? We know that the different elements that exist in nature are synthetically we prepared, that is the man-made elements. Now the different elements possess different physical and chemical properties, different atomic number and the different mass number. Therefore, our objective is to segregate the elements that possess the same property, either with respect to the atomic number or with respect to the atomic mass or with respect to the electronic configuration or with respect to the atomic masses of the elements. Now in 19 in 18th century, whenever the 30 elements were discovered, at that time, that in 1829, Davanagere, he classified the 30 elements. They classified the elements on the basis of the triads, and the basis of the triad rules. Now see, in triad rule, suppose the lithium and sodium and potassium, these three elements are considered as a triads. These three elements are considered as a triads. And here suppose the chlorine and bromine and suppose iodine, these three elements are considered as a triads. For example, now the mass of this middle element is the average masses of these remaining two elements. Now suppose the atomic mass of this sodium, that is the average atomic mass of the lithium and that of the potassium. When you calculate atomic mass of sodium is equal to average atomic mass of lithium and potassium. Suppose the average atomic mass of this atomic mass of the potassium is found to be, that is atomic mass of lithium is found to be 4, and atomic mass of the potassium, hydrogen, helium, now that is a 39, atomic mass is 39. Now this is 23. Now this is found to be 7 point something. This is found to be 7 point something. This is 39 point something. That is a 46. Half of this value is equal to 23. Therefore, the atomic mass of the sodium is found to be 23. When you determine the atomic mass of the bromine, that is equal to the atomic mass of the chlorine plus atomic mass of the iodine divided by means of 2. That is how we cannot get the atomic mass. What about the importance or the significance of the triad rule? By using the triad rule, they organized the 30 elements on the basis of the triad formula. According to the triad rule or the triad formula, the atomic mass of the middle element, that should be the average atomic masses of the adjacent different elements. For example, atomic mass of sodium is equal to the atomic mass of lithium plus atomic mass of potassium divided by 2, and atomic mass of the bromine is equal to atomic mass of the chlorine plus atomic mass of the iodine divided by 2, and hence we have this triad rule. But in 1864, Newlands, he proposed the new distribution of the elements. In 1865, Newland, he proposed the octave rule, new octave rule. New octave rule, law of octaves. Newland. In 1829, Davanagere proposed the triad rule. In 1865, the Newland that proposed the octave rule. Oct that corresponds to the eighth. Therefore, according to this octave rule, here after eighth element, the same property that repeats. For example, when you come across lithium and sodium and potassium, therefore lithium, then add 8 different elements. After next 8 different elements, sodium repeats. Then after sodium, 8 different elements, the potassium repeats. Therefore, like that of the Sari Gama Pa, that is the 7th, then 8 that repeats. That is Sa Ri Ga Ma Pa Da Ni. Therefore, Sa Ri Ga Ma Pa Da Ni. This is first, second, third, fourth, fifth, sixth, seventh. Then again the Sa repeats. Again that Sa repeats. Therefore, Sa Ri Ga Ma Pa Da Ni. Therefore, again Sa that repeats after the 7th element. Therefore, this 8th element that possesses the same. Sa Ri Ga Ma. Now, and hence Sa Ri Ga Ma Pa Da Ni Sa form, the different elements were organized. Different elements were organized. Different elements were organized. Therefore, this is the atomic number 11 and this is atomic number 19. Therefore, assume this is 11, this is 12, 13, 14, 15, 16, 17, 18 and so on. Sa Ri Ga Ma Pa Da Ni Sa. Now, according to this octave rule, new octave rule, after 8 elements, the new element that is obtained, they shows the same properties. That is why lithium and sodium, potassium, they exhibit the same properties. That is true in triad rule, that is also true in case of the octave rule, new octave rule. Now, they organized, there exist, that is 63 elements which are found in 1865. The Newland proposed the new formula for the distribution of the elements in particular group and periods. Therefore, he divided these elements into 8 cross 7. He divided the elements, that is 8 groups and 7 periods at the time in Newland projection. That is 8 groups and 7 periods. Therefore, in 8 group that he discovered on the basis of the Sa Ri Ga Ma Pa Da Ni Sa, and the first element, assume that is lithium is the first element, it exhibits the same chemical properties of that of the sodium. The sodium exhibits the same chemical property that of the potassium. Therefore, whenever the number of elements that exceeds, there is a tough task for the researchers and the scientists to organize the elements in a different manner, whether they based upon the atomic number, whether they based upon the mass number, whether they based upon the physical properties, whether they based upon the chemical properties, or whether they based upon the electronic configuration. So many parameters are there for the organization of these elements in the modern, in different groups and the periods. Then afterwards, they propose the new formula for the whenever the number of elements that exceeds to certain limiting extent, that is exceeds. Therefore, the task is between that is a scientist how we can organize. Therefore, they thought that some parameters that repeats after several times they discovered, and hence they classified the elements in the different groups and periods. Now existing, we have the modern periodic table that consists of 18 different groups and 7 periods. 18 groups and the 7 periods. What is the objective of the classification of these elements in the modern periodic table? Modern period table. They are classified into 18 groups and 7 periods. Why these elements are classified into 18 groups and 7 periods? That already that I mentioned, S atomic orbital has capacity for the accommodation of 2 electrons. P atomic orbital has capacity for the accommodation of 8 electrons. And D atomic orbital has capacity for the accommodation of 18 electrons, and F atomic orbital, 10 electrons, and F atomic orbital has capacity for the accommodation of the 14 electrons. 14 electrons. Now see the modern periodic table, existence of the modern periodic table. They are classified into first period. They are classified into first period and second period elements, and third period elements, and third period elements existing, and fourth period elements, fourth period element, and fifth period elements, and sixth period elements, and seventh period elements. How many number of elements are present in the first period? Only 2 elements are there. In second period we have 8 elements are there. In third period we have 8 elements are there. In fourth period we have 18 elements are there. In fifth period also we have 18 different elements are there. In sixth period only we have 32 elements are there. Here not completed. This is seventh period. Incomplete period. More than 50 elements are there. In this seventh period. See, the vertical columns and horizontal rows. These vertical columns in the modern periodic table, that is from top to bottom, and horizontal rows, that is from left to right. That is horizontal rows and columns. Now what are groups and periods in the modern periodic table? Groups and periods. Groups are nothing but the vertical columns. Horizontal rows are considered as periods. Now there are 7 periods. And 18 groups are there in the modern period. 7 periods and 18 groups are there in the modern period table. Why we have only 18 groups in the modern period table? In S atomic orbital we can accommodate 2 electrons. In D atomic orbital we can accommodate 10 electrons. In P atomic orbital we can accommodate 6 electrons. Therefore 2 plus 10 plus 6 is equal to 18. Therefore we can accommodate only 18 elements in 18 group. We can classify this modern period table into 18 groups. Therefore 18 groups are because of S atomic orbital complete octet, D atomic orbital in complete octet, and P atomic orbital in complete octet state. When they will be organized, then we have total 80 number of the electrons. At the bottom of the modern periodic table, we have 14 different groups, and therefore 28 different elements are there. And this one is called as a actinide series and lanthanide series. One series is actinide series and one series is lanthanide series. Therefore 2 series are there. Each series consists of 14 different elements, that's 14 groups. Therefore 14 groups and 2 periods are there at the bottom of the modern period table. That is around 28 different elements are there in F block elements. Okay. Now the shortest period. That is the first period. That consists of hydrogen and helium, only these 2 elements. Second period is the short period. Second period. Here we found that lithium is the starting element and neon is the last element. Total 8 elements will be there. That is hydrogen and helium, these 2 elements only present in first period. Lithium onwards. Lithium, beryllium, boron, carbon, nitrogen and fluorine and neon. Different elements are there. Now the lithium to neon. Whereas the third period, That is, starting element is sodium, the last element is argon. Again we have total 8 different elements. Sodium, potassium, that is a sodium, magnesium, aluminum, silicon, onwards up to chlorine and argon. These 8 different elements will be there. Now the fourth period, we have totally 18 different elements, that is starting from potassium and krypton, helium, neon, argon, krypton. Then xenon is the last element in case of the fifth period, that start with the lithium, sodium, potassium and rubidium. Here also we have 18 different elements are there. 18 different elements are there. And sixth period, it begins with cesium and it ends with the radon. We have 32 different elements are there. 32 different elements are there. These numbers are very important in memorization of the elements in the modern periodic table, and these numbers are called as a magic numbers. These numbers are considered as a magic numbers. Numbers are considered as a magic numbers. See the first number. Therefore here, by now this is 10. Add these two, it becomes 10. Add these two, it becomes 18. Add these two, it becomes 36. Add this up, it becomes 54. Add all the elements, that becomes 86. It becomes 86. Therefore, remember any simple element, keep it in your mind. Suppose the element with atomic number 1, keep it in mind. Add the first magic number, then the second is found to be 3. Add next magic number, then next found to be 11. Next magic number, that is found to be 19. Next magic number, that is found to be 37. Add next magic number, it is found to be 50, that is 55. Therefore, this corresponds to the hydrogen, this corresponds to the lithium, this corresponds to the sodium, this corresponds to the potassium, this corresponds to the rubidium, this corresponds to the cesium. This corresponds to the cesium. Now last one is a francium. Now add the next magic number, that is found to be 87. That corresponds to the francium. If once the element is known, the other element that can be automatically we can remember. Therefore, atomic number 3, 4, atomic number 11, atomic number 12, atomic number 19, atomic number 20, atomic number 37, atomic number 38, atomic number 55, atomic number 56, atomic number 87, here atomic number 88. Similarly, we can memorize the different elements in the modern periodic table. Memorize the different elements in the modern periodic table. Okay? Now the existing is modern periodic law, modern periodic table. Modern periodic table. According to the modern periodic table, the physical and chemical properties of the elements are the periodic functions of their atomic number. This is very important. Physical and chemical properties of the elements, they are based upon their atomic number. Based upon their atomic number. Is it clear? In the beginning, they thought that they based upon the atomic weights. But whenever they found that the newer elements they possess higher mass number, then their element would be unstable. For example, in F block elements. F block elements usually possess the higher mass number, therefore their nucleus is not stable. They possess unstable nuclei. That is why they emit alpha, beta and gamma radiations and tries to attain the nearest noble gas configuration. That is the reason why there are certain limitations are there. Only up to certain extent that is true. The physical and chemical properties are the periodic functions of their atomic weight. This holds good only for the elements with lower mass number, lower atomic mass. But whenever the new elements are discovered, then the task that is found in the arrangement of the elements based upon their atomic weight or the atomic mass or the mass number. Therefore, the scientists proposed the new law, that periodic law, that based upon atomic number. Therefore, physical and chemical properties of the elements, their periodic functions of their atomic number, that not mass number. Mass number that holds good for some extent, but that limitations will occur. Therefore, nowadays we are using this modern periodic law where the physical and chemical properties of the elements are the periodic functions of their atomic number. Is it clear? Now, on this basis, the elements are classified. On this basis, the elements are classified. Now, how the elements are classified? You know about electronic configuration. Electronic configuration. Electronic configuration. On the basis of the electronic configuration, where S1 exists and S2 exists, S3 does not exist in nature. S3 does not exist in nature. Whereas the P1 exists and P2 exists, P3 exists, P4 exists, and P5 exists, and P6 exists, P7 does not exist. And D1 to D10 exist. D1 to D10 exist, and D11 does not exist. D11 does not exist. And F1 to F14 exist. F1 to F14 exist. F15 does not exist. F15 does not exist. Is it clear? Because S atomic orbital is the spherical shaped atomic orbital. S atomic orbital is the spherical shaped atomic orbital. Imagine the diagram of the sphere. Imagine the diagram of the sphere. Diagram of the sphere. Here, when you cut the sphere into two equal parts, upper half of the sphere carries one electron that rotates in clockwise direction. Lower half of the sphere that carries one electron in anti-clockwise direction. Therefore, 1 plus 1 that is equal to 2. That is why we can accommodate two numbers of the electrons. Very important. S atomic orbital is non-directional atomic orbital. S atomic orbital is non-directional atomic orbital. It has no direction. Non-directional. S atomic orbital is non-direction. That is why we can't predict Sx, Sy, Sz like that. Sphere has no direction. Sphere has no direction. But dumbbell has a direction and double dumbbell has a direction. That is why in px atomic orbital, in px atomic orbital, in px atomic orbital, in px atomic orbital, here we can accommodate one electron. Here we can accommodate one electron here. Here we can accommodate one electron here. Therefore, Px is capacity for the accommodation of two electrons. If it rotates in clockwise direction, it rotates in anti-clockwise direction. It rotates in anti-clockwise direction. Therefore, Px, two electrons. On the basis of the electronic configuration, we can arrange the elements, it is elements in the different electronic configuration in particular group. For example, S1 configuration in the same group and S2 configuration in the same group, and P1 configuration in the same group, and P2 configuration in the same group, and P3 configuration in the same group, and P4 configuration in the same group, and P5 configuration in the same group, and P6 configuration in the same group. P6 configuration in the same group. That is why S1 configuration and S2 configuration. Then you know that NS1 configuration and NS2 configuration. N stands for the principal quantum number, that indicates the shell number. The power 1 stands for the total number of the electrons that present in an atomic orbital. By putting n is equal to 1, 2, 3, 4, 5, 6, 7 and so on, we have 1s1 configuration, 2s1 configuration, 3s1 configuration, 4s1 configuration, 5s1 configuration, 6s1 configuration and 7s1 configuration. For existing elements, we have principal quantum number value that ranges from 1 to 7. For existing elements, the principal quantum number value that ranges from 1 to 7. That is why 7 periods are exist in the modern period table. In future, we can have the 8th period, 9th period and so on. But the element which is found recently, that possesses the 7 different shells. Therefore, principal quantum number is equal to 7. What is this shell number? That is the orbit number. That is the main energy level of an electron. Main energy level of an electron. Here NS2, by putting n is equal to 2 and so on. Therefore, by putting 2s2, 3s2, 4s2, 5s2, 6s2 and 7s2. That is why see the Octave principal diagram or energy level diagram. In the beginning we have 1 to 7 numbers, 1s to 7s. Second we have 2, that's P2, 6P, sorry 7P. That is why first period we have only 2 elements, second period we have 8 different elements are there. S2, that was 2s2. 1s2 is not there, 1s2 is helium. It belongs to the 18th group of the modern period table. I will explain later. That is why 2s2 and 3s2 and 4s2 and 5s2 and 6s2 and 7s2. 7s2. Now usually check elements with the first group, like that of the hydrogen or lithium or sodium or potassium or rubidium or cesium or francium. Always they possess S1 configuration in the outer atomic orbital. Irrespective of the principal quantum number value, S1 electron will be there. That is why all the elements that falls in the first group of the modern period table, they possess the outer electronic configuration as a S1 configuration. In general, we can predict it as a NS1 configuration. N corresponds to the principal quantum number. Its value is 1 to 7. Its value is equal to 1 to 7. Whereas in case of the second group of the modern period table, when you write the electronic configuration of any element starting from the beryllium or magnesium or calcium or strontium or barium, whatever it may be, it always ends with S2 configuration irrespective of the principal quantum number. Therefore, 2s2, 3s2, 4s2, 5s2, 6s2, 7s2 is there for the elements belongs to the second group of the modern period table. Therefore, only electron will present in s atomic orbital, outer, that is to outer s atomic orbital. Therefore, the properties are same because they have only 1 electron in the first group and there's 2 electrons in the second group. Therefore, the chemical properties of the elements of the first group are always same. Only physical properties like density, melting point, surface tension, viscosity, these are the different. But chemical properties of the elements, because 1 electron is there, their periodic properties are also same. That is the properties, chemical properties are same. Where the second group we have only the 6 elements are there, starting from that of the beryllium. Beryllium has 2 electrons, S2 atomic orbital, S2 electronic configuration, outer electronic configuration. Magnesium have S2 configuration, calcium have S2 configuration. Similarly, strontium or barium have the S2 configuration, irrespective of the principal quantum number value. Principal quantum number value that ranges from 2 to 7, whereas the 2 for this beryllium, 3 for this magnesium, 4 for this calcium, and so on. We have the principal quantum number values that's different, but the power of, that is the number of the electrons retained by the s atomic orbital is same. Therefore, in these two groups, the electron will enter only in the outer s atomic orbital. Of course, so many inner atomic orbitals will be there, but property that is decided by means of the valence electrons that will appear in the s atomic orbital, in most precise, this is outer s atomic orbital, outer s atomic orbital. Is it clear? Therefore, the group of the elements for which the valence electrons are present only in the outer s atomic orbital of an atom, they are called as s block elements. Now, very important, recently we classify the elements on the basis of the particular blocks, whether it belongs to S block or P block or D block and so on. Therefore, the group of elements or the set of the elements for which the valence electrons are present only in the outer s atomic orbital of an atom, they are called as the S block elements. Usually in board exam, very important question, how the elements are classified based upon their electronic configuration, or what are SPDF block elements. This is very important question for your annual board exam preparation. Now, S atomic orbital valence electrons are present, they are called as S block elements. If the valence electrons are present in P atomic orbital, usually P atomic orbital most precise is outer P atomic orbital. So many P atomic orbitals will be there, but the electrons will usually present in the outer P atomic orbital. Those set of the elements are called as the P block elements. Very important, group number 1 and group number 2 elements are called as the S block elements. For group number 1, we have the valence, that is the general electronic configuration is NS1. For the group number 2, we have NS2 configuration. Therefore, what are S block elements? Please remember, S block elements, S block elements, S block elements. Group number 1 and 2, group number 1 and 2 are called S block elements. Electronic configuration, electronic configuration. For group number 1, we have 1s1 configuration, ns1 configuration. For group number 2, we have ns2 configuration. Here n ranges from 1 to 7. Here n ranges from 2 to 6. N ranges from 2 to 7. N ranges from 2 to 7. This group number 1 elements are called alkali metals. Group number 2 elements are called alkaline earth metals. Alkali metals except hydrogen. Alkali metals except hydrogen and also francium. I will tell later why in any particular group the last element is not included with respect to the periodic properties, because with the elements with the higher mass number, they possess unstable nuclei. When you particulate down the group, the francium is the last element in first group. Therefore, with down the group, the mass number gradually increases. Therefore, francium possesses unstable nuclei. Therefore, excluding this hydrogen, which is a non-metal, and francium that possesses unstable nuclei. Therefore, the middle 5 different elements are there, like that of lithium, sodium, potassium, rubidium, cesium. These elements are called as alkali metals. How many alkali metals are there? The 5 different metals are there here. 5 metals are there. 5 metals are there. 5 metals are there. Okay. Thank you. I'll continue in next period.